All right, so this is still day 5. Complementary angles and trigonometry is what we're going to be going over next. This is number 7 from day 5. And this is probably going to be a bit of a shorter lesson. We've already talked about what complementary angles are. Complementary angles are angles that add up to 90 degrees. And when we use trigonometry for right triangles, we have to know um, a specific rule about complementary angles. And this rule comes up probably in most likely you'll get exactly one question on this topic. And that's why we're not going to spend a whole lot of time on it. But you might get a couple of other questions on trigonometry rules, which is sine, cosine, and tangent. So for complementary angles, these add up to 90 degrees. Let's look at an example in a triangle here. Here we have all 3 of these angles in the triangle. The uppercase letters are the angles. The lowercase letters, they correspond with the angles. So they are the side lengths, they're the smaller letters, and they correspond with the angles that have an uppercase capital letter. So that's always going to be the case when we're labeling these triangles. Here it says the measure of angle A plus the measure of angle B. That's what the M stands for there, equals 90 degrees. Let's try to make sense of why that is. So this is a 90-degree angle at angle C. All triangles have to be 180 degrees. So because of that, we've already used up 90 degrees of that. That means that A plus B has to also be 90 degrees. So we can write this with notation like angle A equals 90 degrees minus angle B. We can also write with notation angle B is equal to 90 degrees minus angle A. So we can write it like this, 90 minus angle B, and this one is 90 minus angle A. So that's how we can write those different angles in terms of A and B with the 90 degrees. Now, when you get to the question like this, it's probably not going to even tell you what this is. Okay, let's do some quick review on sine, cosine, and tangent. So you probably heard the acronym SOHCAHTOA in your geometry or math class. And if you haven't, that's okay. We'll go over what all that means. It's just an easy way to remember sine, cosine, and tangent. So we say this is the equals part, and this part's the dividing by part. So if we want to find the sine of any angle, I'm going to use numbers first. That might be easier. If this is 35 degrees, and if we know that this is 3 and this is 5, actually, I'm going to erase the 35 and we'll just say 3 and 5 for now, because those 3 numbers might not end up matching up. So for sine of A equals sine equals opposite over hypotenuse. Opposite is little a. That's where we get this little a from. And hypotenuse is little c. That's hypotenuse is always opposite of the 90-degree angle. So that's how we get this formula for sine A. Now, if we want to actually find what sine A is, we would just write sine A equals 3 over 5. And if it asks you to find what angle A is, you would take the inverse sine and think of it almost like we're multiplying by inverse sine of both sides. And so when we do this, that crosses out with that. And we're just left with angle A. And then on the right side, it's inverse sine 3/5. And you can write that like a decimal. But this is how you figure out what the exact angle is with trigonometry. So you can do inverse sine 3/5 on your calculator. Just make sure your calculator is in degrees. You go to mode, or actually, I think it's math. And it's been a while since I've actually set my calculator to degrees or radians. Might take me a second here to figure that out. Oh yeah, you can click mode on your calculator if you have a TI-84. And that's a really common graphing calculator. Mode is on the upper left, and then there's radians and degrees. So you want everything in degrees. Most likely the calculator that you have is already going to be set in degrees. It's going to say DEG. So you do inverse sine 3/5, and we get 36.869 or 87. So that's how many degrees the angle A is. This is just some quick trigonometry review. If you don't know trigonometry and this doesn't make sense to you, definitely check out Khan Academy. Type in sine, cosine, tangent, or just type in basic trigonometry rules or trigonometry and right triangles. That can also help you out. Okay, so now these are some rules that we have to sort of remember. The key takeaway is this. Since this is equal to 90 minus angle B, and this is 90 minus angle A, essentially we can say that sine A equals cosine B. This is something we just have to memorize for this part. And sine B is equal to cosine A. Let's look at why that is. So sine A is A over C. It's opposite over hypotenuse. That's what sine A is. And cosine B is, cosine stands for adjacent over hypotenuse. So now if we're looking at angle B, the angle next to it is A. That's the adjacent. The adjacent can never be the hypotenuse. So that's how we know it's got to be A for the adjacent. And then C is the hypotenuse, C. So we get A over C equals A over C for this. Same thing with sine B and cosine A. Sine B is B over C, and cosine A is B over C. That's all this stuff is saying. Now this says sine A is equal to cosine A minus 90. Well, that makes sense too, because this is sine A. Sine A is A over C. Cosine 90 minus A, well, that's just B. That's just another way to say cosine B. This is 90 minus A. Same thing over here. Sine 90 minus B, which is the same thing as sine A. That's 90 minus B right there. This basically just says sine A. This basically just says cosine B. So these are just rules that we have to sort of remember for the test. So if you know that rule and you know that idea, you can solve problems like this where it says, if we have this right angle, right triangle, sine A is 0.2, what is cosine B? So sine A is 0.2. We'll just say that's 0.2. And it says, what's cosine B? Well, cosine B, 90 minus A, that is B. That's 90 minus A. So that's cosine B also. So it said earlier that sine A is 0.2. It wanted us to find cosine B. Well, that's just the same thing. They're both equal to 0.2. And if you have a decimal for sine A for 0.2, that's kind of like saying A over C or 0.2 over 1. That's one way you could write that ratio. Let's look at one more. It says sine 90 minus A, that's B. B is 90 minus A. And we want to know, or it actually tells us what it is. It says that that is 12 over 13. So opposite is 12. Hypotenuse is 13. So it's saying that's what sine, let me write this way. That's what sine B is. Sine B is 12 over 13. Erase that. It's actually just easier to see it that way. Now it says, what is sine A? Well, sine A, we'll do that in blue. Sine A, that's going to also be opposite over hypotenuse, except our opposite, our little a, we don't know what that is. So far we have an equation that says this. Sine A is little a over 13. We have no idea what that is. So we have to figure out what little a is. And we do that with Pythagorean theorem. And it says a squared plus b squared equals c squared. A squared, which we don't know. B squared is 12 squared. C squared is 13 squared. We have a squared plus 144 equals 169. And then we just subtract from that. We get a squared is equal to 25 and a equals 5. Okay, so just kind of like the last problems, we have to double check to see what the question's actually asking us. It's not just asking us to find a, little a, it's asking us to find what is sine A. The sine A, I did that in blue earlier, I'll try to get the same color. Sine A is five over 13. Now, if it asked you for what angle A was, which it didn't, you could do inverse sine on both sides. You could type second sine on your calculator. That's how you do inverse sine. And then you can just type 5 over 13. And you get about 22.62 for the actual degrees of A. But this one's just asking us, what is the fraction? And the fraction is 5 over 13. Okay, let's see. I think maybe we might not have time for another example. Let's look at one more here. It says ABC, CD is drawn to AB such that AD equals BD. So we can mark these like this. AD equals BD. And it says cosine DCA is 0.43. So DCA is this. We're going to assume that's a right angle, I believe. Yeah. Yeah. So it says cosine DCA is 0.43. That's this one. Cosine is adjacent over hypotenuse, which is going to be little a, or we'll call that, call this little d, and this is little c. So this is going to be 0.43 is adjacent over hypotenuse, DCA. This one might be one of those that we have to memorize. 0.43 of cosine DCA. I'm going to write it like this, 0.43 over 1. So that's adjacent over hypotenuse. So 0.43 over, but we don't know what the hypotenuse is either. So we've got two missing values here. So I believe this is one of those where we have to memorize. Let's go down to the solution here. Yeah. Basically, it just says because cosine of that angle is given, that equals the sine of that, the other angle that's opposite of it. But let's look at the two angles that it's talking about. So it's talking about this angle, and it's talking about BCD, which is this angle here. So I think this is a very complex problem. If you guys have questions about the answers, we can certainly go over some questions either at the end of class today, if there's time, or next class. But you're probably not going to see a question like this where there's two triangles inside of themselves. But you are going to see questions like this asking you to find the missing values of sine, cosine, and to identify that angle B is 90 minus A and angle A is 90 minus B.